I have too many ideas per minute, and my home is filled with many of those ideas. Sometimes it's art, sometimes it's utility, sometimes it's both. Those are my favorite. So why not let that bleed over into my office? Today, my office door becomes the canvas, and the idea is to attempt the largest 3D carving in the history of CNC routers. Can I execute a life-size reptile replication, or will this project eat me alive? A build worth bleeding for is what's in store. Our last couple of videos have featured some software heavy lifting. Chair construction and multi-level inlays can be mind-bending. I was up for a break from that mental exercise. This left me free to experience actual heavy lifting. The door blank being fed into the Shapeoko is a ridiculous 88 by 40 inches. Weight, 100 plus pounds. But at 6'6", 215, I should be able to handle it. Should. Full disclosure, this is the second door blank I made. Here on the channel, I enjoy sharing my failures so you can avoid some of those same pitfalls. The details on that failed first attempt are coming up, along with a bunch of useful pro tips and concepts which will make all of your upcoming projects better. Now, computer work is always a necessary step. Here, Carbide Create Pro is going to make quick work of bringing this killer STL into the build. A single-step import has the gator as a component inside of our model tab space. With the new editability of those components now available in Carbide Create 8, there's no excuse not to give a little 3D kick to your next project. You should know I paid for this file. Paying for a decent file, that's a good idea once in a while. Here I decided to scale the reptile to the full door size. By going full width, the head of the gator gets huge, but setting out to retrofit the door frame, measurements and remeasurements were required. 1.4 inches is the current thickness of the door. Hitting that depth will require me to incorporate some 2D elements inside the 3D modeling aspect of this project. Utilizing a guides layer, along with basic shapes, goes a long way to accomplishing this integration of 2D elements. There I put measurement guides and sometimes notes. I utilize this type of layer on many of my projects. The toolpathing will later create the exact dimensions required. And here's a key bit of understanding which may help all of your designs. In the 3D modeling tab, I create a simulation of the entire door to assess my design. However, when I set out to toolpath the project, I'll only utilize the center portion of that 3D modeling design. Understand that these two workspaces, the Model tab and the Toolpathing tab, operate independently. Your final project results are determined solely by the Toolpathing tab. You decide how much of your Modeling tab creation to include in the final project through your Toolpathing choices. In this case, the interior of the door will match the Model tab simulation, while the outermost features of my door are defined by traditional 2.5D toolpathing. No matter the size of the 3D carving incorporated into the design, Carbide Create shines with simplicity during toolpathing. 2 toolpaths is all it takes to create any 3D element. In addition to 3D elements, this project also requires tiling. Tiling allows you to create projects that are infinitely longer than your machine. This is useful for sign work and apparently for movie prop style door projects. Tiling has some physical requirements that must be followed for success, and I'll get to those when the main project is underway. We have a video about the tiling process which is linked in the description. Now, the hinges are in similarly exact positions. Getting those properly transcribed after door production is complete will require different tools and skills, along with measure twice, cut once. And that is a main feature of this project because there is no going back. Failure is 100% possible on this build, and at one point I thought that possibility had become a reality. Now, I know you want that 3D tool info. Trust me, I've got it for you. The exact endmills, costs, feeds, speeds, and all those deets are coming up. When the stakes are this high, I like starting with some small scale testing. The tiling feature of Create is ultra handy and it has some definite nuance required for success. Fortunately, testing can be done at any size. Wanting to check my workflow and the file, I embarked on a 2-step verification process. Looking first to inspect the detail of the file, I cut a mini gator. This little fella was made with smaller endmills to express those details. Be sure and stay tuned for a quick analysis of the level of detail and endmill selection. That understanding will help optimize your machine time and results on any of your 3D projects. Here, I like the mitigated results, so it was on to a tiling test. I set up a small test to dial in that workflow, and I recommend you do the same when you're unsure of the exact steps needed to accomplish any task. I imported the STL, extruded it to the maximum possible inside the available depth of my material. Walnut, of course. I then activated tiling and set the tile size at 10 inches. I selected that first tile and positioned my stock accordingly. 2 tiles, 1 slide operation between them, and bang, I have a tray with a fine-looking juvenile reptile. Accurately sliding the stock between tiles and ensuring that stock moves exactly square to your machine is how perfect results are achieved. More details on that are on the way during actual door creation. Here, tiling workflow test, check. Back to that blank for a second. As with any version 2, things were learned and alterations were made. In V2, a sheet of 1/2-inch plywood became the basis. That Baltic birch backer will add some structural flatness. To that base, I added 2 layers of planed 6/4 pine. Final depth, 3.125 inches. The blank looks a little wonky, but I laid out the measurements inside Create so that the blank depth matched the design requirements. I didn't need to mill away massive amounts of material. This project was already going to make the entire shop smell pine fresh all week. Gluing up the framework here was also challenging. As it turns out, making doors is a specialized field with specialized methods and tools. My DIY ambitions are treading into some deep waters here, hence the danger of failure and the excitement of possible success. But mid-project, I'm mostly filled with questions and concerns. Does that sound familiar? Let me know in the comments below. When operating at the edges of a machine, the workholding can quickly require unique solutions. For this project, I constructed brand new left side edge guides. More on those when we slide the blank for tile 2. In constructing the blank, I did create a fortunate circumstance and made a discovery that will inform all of my future projects. The 1/2-inch plywood layer was left wider than the stacked pine, creating a 1/2-inch rim around the entire blank. This allowed me to clamp the blank at a 1/2-inch height rather than a 3¼ inch height. Trust me when I say workholding 1/2-inch material is a cakewalk compared to 3+ inch stock. Put that idea in your CNC workbank for the next HD project you design. It could help you down the road. When it comes to clamps and bolts, I have a ton of flexibility. Some of it has been built by project demands over time. Some of it results from the different clamps we've had over the years. You'll never regret spending money on workholding. Never. With that rim, I was able to use basic essential clamps, those ones that come with your machine, for much of the blank. I did move to some aluminum versions from the Carbide 3D historical record, and when I got to tile 2, the top edge presented a unique challenge. I solved it with old Nomad clamps, blocks from our Essentials Pro kit, and some random aluminum I had on hand. Workholding can be as creative as the projects themselves. You may even find yourself machining some workholding for another project. Owning the means of production is a beautiful thing. The tools for this job started with a 3-flute upcut 1/2-inch flat end mill for roughing, then utilized a 3-flute 1/2-inch ball end mill for the finishing. And after hours of machining, the overall product on tile 1 was a huge win. The blank performed at 98%. That final 2% wasn't anything that couldn't easily be fixed with a Dremel. These small sections failed due to cutting forces applied to a depth matching the glue line between the layers of pine. I'll show you exactly how to make those disappear when we pull the cut blank off the machine. A little bit of artistic sculpting should do the trick. But the execution of tile 1 was not without issues. There was some collet contact. Even with that 3.5-inch end mill, I didn't leave enough stickout to complete the roughing operation along the border of tile 2. Hitting the edge of that wall was a bummer. Now, reinitializing the machine was easy enough. After a practical error like this, the Shapeoko will return to the zeros you've previously set. I considered editing the G-code and picking up with the roughing where the contact had taken place. But I was close enough to the final roughing depth that running the finishing pass was well within range for the 1/2-inch finishing end mill. This is due to the tiny step over utilized by a finishing operation. That value, 10 to 15% of the stock step over, allows you to consider skipping a roughing pass on some projects. The remaining depth on this blank was small enough that the finishing end mill was definitely up to the task. So I loaded up the ball end mill, let the hours click by, and watched the first half of this monstrosity come to life. Tile 1 is complete. When tiling, it's critical that the material blank move in line with your gantry. This means those left side edge guides are 100% needed on this project. You've seen me use these before, and I recently updated the file on CutRocket. You'll find the link in the description. To ensure proper alignment, these edge guides must be cut with your machine after being installed in the outermost row of T-tracks. During install, be sure and drop a few tease nuts between them for work holding. This is why I don't make a left side edge guide which is continuous along the entire Y-axis. By the way, tease nuts are cheap. Buy them, fill your machine with them. Future you will thank you. Now, for the slide on any tiling project, the movement of the blank must equal the specified tile size. During my testing, that number was 10 inches. Here, 40 inches is the distance. The accuracy of this slide is critical, not only for the design, but also for the final dimensions of the door. This thing has to be 80 inches tall or it will not fit in the existing frame. Sliding short or long will have exactly that effect on your final project. I'll tell you this, I nailed the slide and the overall size of the door is dead on. Hours upon hours is what this project took. Even with that half-inch tooling, this was a big undertaking. The final tally is well over 24 hours of machining. This sounds like a pain, but come on, the results are ridiculous. It's so much fun to be pushing the machine, myself, and the material. For a project like this, you have to love being on the edge of possible failure. It's that high wire act that keeps me engaged. What's possible? Can I accomplish some weirdo project just to have climbed the mountain? When that 10 to 15% step over in the 3D finish pass is complete, any project will require minimal sanding. In some cases, you might not do any post-processing at all. Here, I'm going to lightly sand the entire thing with 220 grit, eliminating some machining marks and this line between the tiles. This depth discrepancy is due to the work holding limitations. On a wide project like this, I would normally put a screw through the middle to the MDF slats. This would provide better control of my stock during both tile cuts. But this design did not allow for that center connection point. Given that this is an organic art project, no one will know anything about those work holding limitations once the line is sanded away. As for those small parts mentioned earlier and lost along the glue line, here's the remedy. A Dremel with a sanding disc and some light hand sanding up to that 220 mark takes care of those flat spots. Because this is art, not engineering, the final shape of the alligator is entirely up to me, the artist. I knew this going in, previous project experience paying off. There's a bunch more advice that's applicable to any of your upcoming projects still to come in this video. Wiping the sweat from my brow, I was tremendously relieved to get this one-of-a-kind cuts off the machine. Having survived a couple of bummer moments, unclamping it all and finding the measurements to be bang on left me super stoked. Now for a couple of other critical operations before the victory parade. The key set. I would use this jig rather than programming in the borehole. This jig is a must. I'm sure there's some 3D print out there these days, or you could just drop by the big box store, sign up for installation of a $35,000 air conditioning system, and grab this jig. As it was, I had to hand router the hole a bit further inward on the door. That doesn't end up mattering here, but the hole location via the jig would have been dead on. Don't be a digital hero, use the jig. When it came to matching those hinge positions, take anything apart and you'll learn about the people who put it together. This applies to cars, homes, tables, and anything else out in the world. What's their level of craftsmanship? How much do they care about details or consistency? Would they make one more trip to the store for the correct part, or just dig into their bag for whatever might get them done quicker? Parts of my house, which the previous owner remodeled, are very much a Where are those random screws I had around? I don't want to go to the store again kind of build. My suggestion, make that last trip to the store for any of your projects. I spent time marking and double checking the measurements of the hinge locations. A mistake here would have the door not fitting into the frame and needing to be cut off or worse in order to be salvaged. Imagine holding the parade of success after getting through the design and 24 hours of 3D machining only to mess it all up with a measuring tape error. No thank you. Key set check, hinges check, check, check. The first time I stood the door up in front of the machine, I was pumped. A mixture of excitement and laughter were the emotions of the moment. What an absurd project. Why do this? Because you can is sometimes the only answer. As I climbed the stairs to my office, a third emotion poured in the mix. Trepidation. Did I cut the hinges properly? Is the key set the correct height? If either of these are wrong, it could mean project death, or at the very least, a whole bunch of work to try and salvage an error of that magnitude. Instead, what I got on installation was reward. It fit perfectly into the frame, but there was just one issue. The inner door jamb on the hinge side was connecting with the edge of the door. No, it doesn't work. I spent time grinding and altering that portion of the frame, only to realize I should simply pry that strip off and nail it back on in front of the new door. An easy fix. Just like that, the door is real, and it's time for finishing. That process began with some light sanding across the entire middle section and then a little more aggressive with the orbital sander to remove that line across the middle. For coloring, I decided to use a furniture antiquing style approach. It began with dye and water onto these pine boards. Pine can be a little bit tricky when it comes to color. After the dye had dried, I went with 2 coats of shellac, followed by a gel coat stain. I went with black, wiping it down, and the color was really starting to come into shape. After that, multiple coats of poly, and that's it. The door is ready to once again climb the stairs, be reinstalled, the frame will be reassembled, and yes, this door is real. Oh, what a moment to put it in the frame and have it look like the Order of the Gator is inside, when in fact it's just my regular office. But it could be something out of Game of Thrones. For the backside, I'm gonna have to put some finish on there to just keep the moisture out of it. But the front is 100% complete. What do you think? How would you have finished it differently? Did it turn out the way you expected? Give me some feedback in the comments below. I'm always happy to hear from you guys. I love the interaction. There are 2 truths in life. Don't eat yellow snow and don't machine green lumber. I'm constantly imploring all of you to get out of the big box stores. Do not go there unless you need nails or an overpriced contractor for air conditioning. Instead, find a hardwood shop and a metal supplier, also a plastic supplier. Places with quality materials and knowledgeable people. That's good advice. And I ignored all of it. Remember that first panel I said I built? Yeah, I made it from standard 2x6 pine. As soon as I started milling, the warpage began. From a flat panel to a concave shell, it took very little material removal to get massive movement. The wood is just too wet. Weather, machining, probably even harsh light would have this wood warping and twisting. All of this to say, go to the wood shop. There you will find properly milled and dried wood ready to increase your possibility of success. Next up, keeping Endmills, collets, and other associated hardware clean. This is important no matter what the project is that you're working on. Here I had a fair amount of pine tar buildup, and this occurred both on my regular Endmills as well as my surfacing bits. I had a couple different approaches to fixing it. One involves some simple green, soaking it, and then brushing away the remaining pine tar. I also went and used alcohol a couple of times, both on Sweepy as well as the Endmills. I found that to be most effective. Here, I'm showing it being scraped away just to show you what we were dealing with. Don't do this with your Endmills. This is for demonstration purposes only. Alcohol, simple green when you're trying to remove pine tar and pine excess. If you're doing a metal project, removing aluminum from a clogged cutter can be accomplished with a lye and water mixture. That collet contact, easily solved with a bit more stick out. There is a blend of cutting depth, stick out, and cut quality to produce that desired final result. But remember, the cut quality is not terribly important on a roughing pass. Always be aware of the ratio of your final depth of cut value and the stick out of your end mill, which will be achieving that depth. Measure it. Yet another use for your calipers. All right, dust collection challenges. You may have noticed on tile 1, I did not run sweepy. Instead, I blew off the machine and vacuumed up chips at the end of the finishing toolpath. This is not ideal. On tile 2, I ran dust collection as much as possible. This did require management throughout the cut to ensure sweepy didn't contact the edges, cause a collision, and lose steps. Deep cuts require extra attention. Please run dust collection. We include it for a reason. The machine needs it, and more importantly, you need it. Next, keep at it. This learning is vital to future success and really why giant projects are something you should take on. Now, I also have some next version changes for you here. If I did another door, first thing I'd do, make the door undersized and glue a frame to it. This would allow for perfect integration to the door frame and greater support for the hinges. Baltic birch plywood or a contrasting hardwood would be my go-to materials. Let's be honest, the solution is always walnut? Yes. Second change, even larger ball end mills. Generally, the bigger the end mill, the less detail possible. However, consider that the finishing pass for the medium gator test tray was accomplished with a 1/8 inch ball end mill. I was happy with the details. That tray is 20 by 5.5. That's 110 square inches. The door checks in at 80 by 35 for a robust 2,800 inches. This means the door is more than 25 times larger than the tray, but the 1/2 inch ball end mill is only 16 times larger than the 1/8 inch end mill. Meaning I could consider going to an even larger ball end mill, which would decrease my machining time while maintaining the same level of detail in my project. This will be TBD on your next project. Balancing details, time, overall size, and cost is part of the 3D creation process. Number 3, leave space for a kick plate. Similar to the full frame idea, I'd probably leave myself a 1/2 to 1 inch at the bottom of the door. After determining exactly how much more was needed on the bottom, I'd cut a strip and glue it to the base of the door. This would allow me some flexibility in the final hanging position relative to the floor, and the addition of a hardwood kick plate, probably walnut again, would be attractive because walnut is always a 10. Which hits directly on the next point, better wood. This is easy and perhaps a function of the client or use. A maple or walnut door would be an expensive build, 2 to 3K or higher for a one-off, but these would be some freaking cool doors. And here's a thought that may not have occurred to you. I've talked before about any design business needing the right clients, the kind of people who can appreciate your creations and craftsmanship, and a client that has the money to patronize your business. That's the whole basis of Patreon, patronage. A person or persons that want to support your pursuits. Anyone ordering a wild custom door is a person with enough disposable income to appreciate and support art. Perhaps your art. Showcasing your capability oftentimes isn't about that particular build. It's about attracting the attention needed to hit a particular vein of new customers. This becomes a fine excuse to make something outlandish and share it with the world. Your imagination will inspire someone else to dream big. Those who dream big and can finance those dreams are the clients you want. The bottom line with all of this, ABC, always be creating. Your skills and results will do nothing but improve. Massive projects beyond your capability are super rewarding. Earlier I mentioned that we're on version 8 of Carbide Create. It's available now for download. The 3D tool acquires that much needed flexibility. You can now alter the parameters of components after you've initially designed them. This is huge! And really the only way this project was possible without me destroying my monitor in a rage of frustration. This has not yet taken Carbide Create Pro to the level of parametric modeling software, but parametric modeling software is generally a nightmare with STL files. So Carbide Create could be the lower friction choice for working with STLs. Remember, software programs are digital hammers. You have several hammers in your shop, each can drive nails. But some excel with certain types of nails. There is no single software solution for your CNC journey. There is only the software you have, the software you know how to program, and the features required for any given project. I hope you've enjoyed this journey as much as I have. When it's time to depart once again, I'll be back with more information, ideas, and inspiration.